Hello guys. So today we're going to be working on functions. Functions is a very fundamental topic in mathematics. It is introduced in grade 10. That's why I got these questions from a grade 10 past paper. However, also grade 11s, grade 12s can use this to practice, use this video to practice because functions do not change. Functions they just add on in grade 11 and 12, but not much really, just like the same concept, something that you can adjust to easily. So my advice is that if you adapt and catch functions now in grade 10, then you're good to go in matric because it's basically the same thing. So I would advise you guys to start mastering functions now. As it is gonna help you in future. So a strategy for functions is that you should analyze and unveil every information that's given to you, because basically when we're dealing with functions, the question gives you the answers to the questions that ask you, not the question, the instruction and the information they give to you basically leads you to the answer. And usually the first questions they ask you for the unknown variables, like the y-intercept, the gradient, the turning points, things like that. So then we should know. And the first thing that you should be able to do is identify what type of function you're dealing with, right? Functions are fun because everything is literally right in front of your eyes. Everything is given to you. That's what makes it fun. So you just have to find the answer to what's being asked. And what you basically need to do. Okay, so let's get in. Let's do the first question, right? So basically, let's note down the information that we have, right? So they said consider the functions f of x, ax squared plus c. Okay, let me write that down. F of x is equals to ax squared plus c, right? What type of function is this, right? We see that this is a parabola. So if you know the function that you're dealing with, then you know the answers to everything. In my opinion, you know what to do. You know what to do. Basically, you have a head start to what you should do. And they say g of x is equals to bx plus q, right? And we know that this is a linear function, the easiest one, linear. So okay, you noted your graphs down, fine. And I want you guys to master sketching. With that, we're gonna do that in question 4.3. Master sketching. Every time you see when they give an instruction without a graph, they're gonna require you to sketch the graph. And if you look at your past papers, sketching is sketching has the most marks. So if you master that, then you're gonna get a lot of marks. So I expect you guys to get total for your functions, because it's 3 marks guarantee. It's easy, if you master it. Okay. Yeah. Information. F and G intersect at A. Right? What's the point A? Point of intersection. Point of intersection. Right? For both graphs, they give you A, -1, -3. So what's the point of intersection? The point of intersection is where both graphs meet, right? They share a point at that. They share a relationship there, right? So they cross paths there. They literally meet each other there. That's a point of intersection. They have the same point there, right? They intersect there. Okay. The second point is B. 2, 0. What do you notice about B? B is 2, 0. And we know that X intersects when Y is equal to 0. So already we have our X intercepts. So we can note that X intercept. And what's the fun part about that? It's for both graphs. We found the x-intercept for both graphs. However, for the parabola, we know that we have two x-intercepts. So we only found one, which is less work for us. So yay, -1 for us, right? They already did that for us. So that's a bonus for us. We should be happy with that. If it's required somewhere, obviously it's gonna be required somewhere. It's math, right? So math is basically systematic. It's systematic. You know what to expect. If you go through these past papers, then you would know how the examiner basically structure these questions, right? You would know what they would want based on the information they have given to you, right? So you see ax2 plus c. They'll obviously want the variables. We do not have a sketch, so obviously want a sketch, so things like that. Okay, just you should, if you go through past papers a lot, you would start thinking how the examiner thinks, and that's when you would expect or know what to expect. You would know what to expect in an exam. So basically, when you see an instruction, then you know what they're looking for, right? So you should really do a lot of past papers in order to see what these examiners are thinking. You would think like an examiner. I mean, if you do past papers a lot, you would think like an examiner. So you would know what you should do immediately, instantly. Okay. So 4.1 says calculate the value of A and C. So 4.1, we want the value of A and we want the value of C. So those basically come from our first graph, which is f of x equals to 8x squared plus c. So we need a game plan. What's our game plan? So now we think, I have 2 points, right? So that means if I have 2 points, I can substitute them, then solve simultaneously. See? So these are basically past knowledge. You would obviously know how to do this because the previous question, which is question 1, the last question of solve for x, was a simultaneous question, was a solve simultaneously question. So you would obviously know how to do that. So math is a build up, right? So if you don't know how to solve simultaneously, then you lost your 4 marks, unfortunately, or you've lost your other 3 marks for the next question. We don't know. So you must learn this stuff, practice this stuff, so that you're ready to go, right? Fine. So first point that we're gonna substitute, point A, -1, -3, right? So I'm gonna say -3 because it's a y, and then A, -1 plus c squared, -3 is equals to A plus C. And then we can say basically A is equals to -3 minus C. We can name that 1, right? Second, okay, let me do side by side. Substitute B to 0, the x-intercept 0, A 2 squared plus C 0, 4A plus C. So we can basically put 1 into 2. I would name this 2, and then I would put 1 into 2. So 0 is equals to 4, negative 3 minus c. So we can solve for c now, basically. So negative 12, negative 4 plus c here, sorry, 0, 12, right? Negative 3c, c is equals to negative 4. We'll find our value for c. Let me note that down. Value for c. Then we punch it back into a. So this is basic simultaneous equation. So there's really not much to this. 3, negative 3, minus 4. Be careful with that. Be careful with that. Minus 3 plus 4. A is equals to 1. Right? Find our answer. Right? So this is just a basic simultaneous equations question, basically. Right? So, so we can note down our formula now that f of x, just for to make things easier, x squared minus 4, right? And we found our 4 marks. Full 4 marks, we get our full 4 marks, right? Okay. Question 2, calculate the values of P and Q. So it's the same concept, different graphs. So 4.2, we know that g of x is equals to bx plus q. Same concept, substitute negative 1, negative 3. Negative 3, b, negative 1 plus q. Basic simultaneous plus q. And then can make q the subject. So negative 3 plus b, 1. Okay, side by side, substitute. This is A, this is point A. Point B, 2, 0, 0, B, 2, plus Q, 0, 2, B, plus Q, 0 is equals to 2B, plus negative 3, plus B. Basically, 1 into 2, right? 3 to the other side, 3B, B is equals to 1. Note it down. Go back to C. Q, sorry. Q is equals to negative 3 plus 1. Then Q is equals to negative 2. Note that down. We can also note our new graph, G of X. Okay, it's in pink. It's fine, it's fine. X minus 2. And that's it, right? That's our formula. Then you get your full 3 marks, right? So it's easy as that. Simultaneous equation. They gave you everything. They gave you 2 points. Just solve. Right? Fine. The next question says, use the answer sheet provided to sketch the graphs f and g on the same axis. So basically, we have our formulas, right? We have f of x. Let me note that down for the new question. 4.3. F of x is equals to x squared minus 4. G of x is equals to x minus 2, right? Just for making things easier, right? So then we have noted that down. So then they said we should sketch these graphs on the axis. So when you sketch, right, you need some information that will guide you into the sketching, right? So this is the information that you need, right? So let me note that down for you. You need the x-intercept. You need the y-intercept. Y-intercept. You need the asymptotes. And you need the turning points. These are the things that will be marked, right? These are the things that will be marked. So you need to note them down. And that's what we're going to find for both graphs, right? So firstly, you need to find the x-intercept. For g of x equals to x minus 2. Remember, previously, they gave us the x-intercept, which was 2, 0, right? Point B. Point B was our x-intercept. So our x-intercept for this is B, 2, 0. Right? Now we need to find for f. If we already have one, we need the other one. So f of x is equals to x 2 minus 4. Make y 0. Then you find x minus 2, x plus 2. So x is equals to 2 and x is equals to negative 2. So it's point B, 2, 0. And we can name the other point P. It's our own. Negative 2, 0. Right, we found the x-intercepts. Fine, let's move on. Y-intercepts now. Y-intercepts. So, let's look at our graphs. G of x equals to x minus 2. F of x is equals to x squared minus 4. Right? Let's look at our graphs. We have a linear graph and we have a parabola function, right? So with our functions, we notice that we already have a y-intercept. The y-intercept is this, right? Because of the nature of our graphs. It's a parabola and a linear. So we can note that our y-intercept is equals to 0, negative 2, 0, negative 4. We're done. Next step, what did we say? We have our x-intercept, y-intercept. Now we're looking for asymptotes. Look at this. Look at these graphs. We have a linear function and a parabola function. Based on the nature of these graphs, do we really have asymptotes? So we don't have asymptotes. So there's no asymptotes. So we take that part because there's no asymptote. Now we go to turning points. A parabola has a turning point, right? Because it has a maxima and a minima, right? So to find our turning point for the linear, we don't have a turning point. X squared minus 4. We're going to say x is equals to negative b over a. It's a formula. What's b? B is 0, negative 0. What's a? A is 1. So this is 0. And then we substitute back the 0. So f of 0 is equals to 0, 2 minus 4. And we get f of 0 is equals to 4. So we find out that our x-intercept, our y-intercept is our turning point. So TP, I like noting it down as TP. So TP is 0 and negative 4. Right. So tick, turning point. Right. So we have all of these points. And intersection, point of intersection, that was already given to us. Intersection. It was B 2, 0, which was our x-intercept, and A, negative 1, negative 3. Fine. Now we can sketch our graph. Okay, so it's not gonna be like a fancy sketch. It's just a sketch. A sketch is a sketch, right? Okay, and you must make sure that the shape looks like a curve or looks like a straight line, right? So let's start with the straight line. So I have one, I have two. This is the x. Sorry about that. This is the x-intercept, right? And what's the y-intercept? -1, -2. So the y-intercept was -2. And we have our point of intersection of -1 and -3, which is somewhere here. As I said, this is just a sketch. We can connect these and sketch the graph. Let me make it in blue. This is g of x. Make sure it's straight, right? Now we're gonna go to our f of x, right? F of x has two x-intercepts. So we just put it there. And it has a turning point here and a y-intercept here, right? So we have to make sure it connects here, here, this point, that point, and that point. It's gonna be so hard, but let's try. Try to make oh my word, okay, let's try. Sorry. I must pass through. Okay, this sketch is a bit ugly, but try to make it a curve. Try to curve it a bit. Try to curve it a bit. I'll try next time. I'll try again next time. Try to make it like nice so you can get marks. Right? I can note that this is point A. This is point B. You'll also name your points, right? So you can get marks. You must label the points. Okay, fine. Okay, second last question. They said, determine the value of g of x minus f of x. So the only way we can find g of x minus f of x is looking at the y-intercepts. That's when we can sum them or make a difference out of them, right? So we're going to go back to your graphs, right? So this point, that's where we can find the difference between them, right? That's that question 4.4. So 4.4, says g of x minus f of x. So the only the way that we can subtract these graphs is when x is equals to 0, and that's the x-intercept. What's the x-intercept for g? Is -2. Minus, what's the x-intercept for f of x? Is -4, right? So -2 plus 4 is equals to 2. And that's basically the length, this length from -4 to -2. That's the length, right? Okay, 4.5, it gets interesting here. So these are the type of questions that you should master and know how to do when you're looking at the graph, right? It says, for which values of x is g of x greater than or equals to f of x, right? So when is g of x greater than or equals to f of x? So basically they're saying, when is g of x greater than f of x? We're going to look at our graph. When is g of x on top of f of x, right? Okay, let me use it different. Look at here, right? You're going to look at this part. This part. Here, g of x is under f of x, right? Fine. So that's not something we should look at. That's not our answer. Okay. Okay, let's look at this part, right? This part. This part. We can see that g of x here, g of x is on top of f of x, right? We go again. We could also see that here, g of x is also on top of f of x, right? So we have a point of intersection here. So basically, they also asked, when is it equals to or greater than, right? So it's between A and B. Point A, it's between point A and B, right? So between point A and B, g of x is on top of f of x, meaning that it's greater than it, right? So now when we do these intervals, we use our x values. We use our x values, right? Fine. So here the x value is -1, and here the x value is 2. And we start from the bottom. So it goes like this, right? The graph is going like this. So we start from the bottom. So we're going to say between -1 and -2. I mean +2, sorry. But how do we note that mathematically, right? And that's what you should master at this point. You're going to say, you're going to put x in an interval, x, right? You're going to say less than or equals to, greater than or equals to. So what's x less than or equals to? X is less than or equals to -1. What's x, what's x, no, here, what's x greater than or equals to is -1. Here, what's x less than or equals to? 2, because 2 is the greater number. And that's basically our answer. Or you can basically say that, you can write it in another notation. You can say x belongs to, right? Then since is equals to, since they require equals to signs, that means you should include the bounds. You should include the bounds, right? What are our bounds? Our bounds are -1. Our bounds are -1 and 2. So it's either you use this one or this one, but they're both correct, right? And that's how we conclude our 17 marks. This question was out of 17. I expect you guys to do this question in, I don't know, but you should do it in like 20 minutes. Yeah, 20 minutes will be sufficient for this type of question, because it's doable. You just need to break down your stuff, right? That's what you need to do. Anyways, thank you so much for watching this video. I hope it helped you, and make sure that when you come across a functions question, you basically unveil all the information that was given to you, because the answer is in that information.